Up until this point, if I've asked you to give me a turning of an angle, you have always given me your answer in degrees. So if I take a look at an example over here, at this vertex, if I wanted to measure a turning, that would be indicated with the arrow as I've indicated here. When we work in degrees, we are not working in numbers, and this is sometimes very restrictive to mathematicians, and so they prefer to work in what we call radians. Now, a radian is a measurement. If I take this length over here, which I call an arc length, and I divide it by the radius of a circle, which is represented over here. If I want a single radian, then I would make my radius equal to 1, and so the arc length of 1 divided by the radius of 1 would give me 1 radian. Let's see how we can convert the angles measured in degrees into radians. If we take a look over here, I told you that a radian was measured by the arc length divided by the radius of the circle. Well, if I have 360 degrees, then that means that my arc length goes all the way around my circle, which is in fact going to be the circumference of the circle, and I still need to divide that by the radius of the circle. As the circumference is 2 pi r, I am now dividing 2 by r, and then by cancelling out the radii, I see that there's a relationship between 360 degrees and 2 pi radians. In other words, if I wanted to know what pi radians were, I could divide both sides by 2. So 180 degrees is going to be pi radians. And if I wanted to know 1 radian is in fact 180 divided by pi. From our discussion, we can see that there is a direct relationship between our measurement in degrees to our measurement in radians. So if I wanted to convert an angle from radians to degrees so that I knew what it was representing, I would have to take a look at either 360 degrees, 180 degrees, or I would take a look at 180 divided by pi to have a relationship with radians. For me, the easiest is always just to take a look at 360 degrees, because we know that that is 2 pi radians. The measurement that's been given to me over here is a measurement in radians, and so the measurement that I want is the measurement in degrees. As I know there is a direct proportion between these, I take the two fractions, I make them equal to each other, I cross multiply, and that way I solve for x. In other words, the missing angle over here, which is 3 over 2 pi radians, is in fact 270 degrees. Clearly, it doesn't matter if I want to know what degrees are in radians or radians in degrees, so long as I understand that there is a relationship between my degrees that is directly proportional to the relationship that I have in radians. I fill in the other missing information that I have, and my variable is in radians. So now if I take my fractions and I cross multiply, I can once again solve for my missing variable x. When I solve for x in this case, I'm going to find that x is going to be equal to pi over 3 radians. Here I've represented my radians as a common fraction. And if I wanted to represent it not as a common fraction, but as a decimal fraction, in this case to 2 decimal places, I would complete it in the exact same way. So in other words, I take my turning in degrees, I equate it to the equal turning in radians. I fill in the missing information, find my variable, create my fractions, cross multiply, and solve for x. When you solve this fraction as a common fraction, you're going to get that the answer is 5 pi over 18. But what would this have been if I'd wanted it as 2 decimal places? All you do on your calculator, you change your simple fraction to a decimal fraction. And when you do that, you'll see that you get a string of decimals. But round to 2 decimal places, this is going to be 0,87 radians. In order to do this, there's just one more thing that you need to know. You cannot work in radians while your calculator is still in degree mode. So you need to change your setup so that you change it from degrees into radians. Very successfully now, you have been able to convert degrees, the turning from an arm to an arm at a vertex, into radians. And the radian measure is a measure of that turning as a real number.